This is the brief on the Trojan Test. For a long time, figuring out if something was a moon or part of a binary system, like Pluto and Charon, relied on a flawed idea called the Barycenter test. Now, there's a much better way to solve this problem, one that actually makes physical sense. Okay, so first, why did the old test fail? It said if the shared center of mass was inside the bigger object, it's a moon. But that's all about size, not gravity. So a big, puffy, low-density object could just swallow that center of mass and get mislabeled, even in a true binary system. Totally misleading. Second, the Trojan test uses Lagrange points. These are 5 spots where gravitational forces balance out, letting a small object kind of just hang out. But here's the key. Only 2 points, L4 and L5, are truly stable. Stable enough to park things like the Trojan asteroids near Jupiter. That stability is the secret. Finally, it all comes down to a magic number, 25. For L4 and L5 to be stable, the big object must be over 25 times more massive than the smaller one. If it's less, the points are unstable, and bam, you've got a binary system. So Earth, 80 times the Moon's mass, passes easily. But Pluto, only 8 times heavier than Charon? Well, that makes them a binary pair. The Trojan test provides a clear physical standard to distinguish a moon from a binary companion based entirely on mass, regardless of size or distance.